Okay, notes 1-3, we're going to be finding the equation of the inverse. So if you remember back from yesterday when we were graphing inverses, all we did was we switched the x and y. So it's very similar. So it says to find your equation of the inverse, you're going to switch x and y, and then you're solving for y. So on number 1, it says write the equation for the inverse of each of the following relations. So we're switching x and y. Make sure you don't take the 4 with the x. You're just replacing your y with x and your x with y. So once we switch x and y, we're going to get y by itself. So subtract 8. You have x minus 8 equals 4y. And then you're dividing everything by 4. In front of x, there's a 1. So you should have y equals 1/4 x minus 2. All right, so the symbol for inverses is a -1 exponent. So that's the symbol for inverse. So make sure you label, once you have got y by itself, make sure you label it. All right, now let's look at number 2. So notice this time that we have function notation. We have an f of x, but remember that is the same exact thing as y. So I'm just going to rewrite this. Instead of f of x, I'm going to put y. Okay, so now what we're going to do is, same thing as number 1, we're going to switch our x and y. And then we're going to solve for y. So I'm going to subtract 7. So we have x minus 7 equals, make sure you look at that closely, that's a -5y. And then we're dividing everything by -5. So in front of x is a 1. So we're going to have y equals -1/5 x. And then a negative divided by negative is a positive, so that's +7/5. Okay, so if you're starting with function notation, make sure you rewrite it and end with function notation. So it should be f of x equals -1/5 x plus 7/5. Okay, also make sure you label the inverse. So it's right after the f is where your -1 goes. So that's inverse of f, function f, equals a -1/5 x plus 7/5. Okay, so notice on number 1 and number 2 that we both had linear equations, and then we ended up with a linear equation for our inverse. Now, 3 is a little different because we are starting with a quadratic equation, but we're still doing the same thing. We're going to switch our x and y, but remember, do not take anything with it. We're just replacing the y with x and the x with y. And then we're solving for y. So we're going to subtract 6. So we get x plus 6 equals 2y squared. And then we're going to get rid of the 2, so divide everything by 2. There's a 1 in front of that x, so you should have y squared equals 1/2 x plus 3. Now, we've done this before. When we were solving using square root method on quadratics. To get rid of the squared, we're going to take the square root of both sides. So we just have a y. And then I'm going to leave it as square root of 1/2 x plus 3. Remember, we've talked about before, anytime we're taking the square root of both sides, you should have a positive and a negative answer. So you need to remember that. Whenever you are finding the inverse of a quadratic equation, you should get a positive and a negative square root equation for your answer. Make sure that you label the inverse. We don't have to change it to function notation because we didn't start with that at the beginning. So when we start with a linear, our inverse is a linear equation. When we start with a quadratic, our inverse is a square root equation. Okay, so let's look at the back. So we are writing the equation of the inverse. And then we're graphing y equals x as a dotted or a dashed line. Then we're graphing the relation and its inverse. Relation is the original. And then, of course, your inverse is your second equation. All right, so the first thing it told us to do was write the equation of the inverse. So that's what we were doing on the front. So we're going to switch x and y and then solve for your y. So we're going to subtract 4. We have x minus 4 equals 2y, and then divide everything by 2. So we have y equals, that's 1/2 x minus 2. I'm going to go ahead and label that as my inverse equation. And then it wants us to graph our line y equals x as a dotted or a dashed line. So remember what that looks like. Y-intercept 0, slopes 1, so up 1, right 1. So there's your line. And then we're graphing the original equation and also your inverse. So I'm going to start with my relation, which is my original. Since it's linear, I'm going to use slope and y-intercept, but if you wanted to plug in some x values to get y values, you can do that. Just make sure you're not using the calculator. So slope of our original is 2/1, y-intercept's 4. So it crosses the y at 4. And we're going up to right 1 for the slope of 2. Down to left 1. That was way off. That's better. Okay, so that was my relation, my original graph. Now I'm going to graph the inverse. So again, it's also linear, so I'm going to use slope and y-intercept. Slope's 1/2, y-intercept's -2. So it crosses the y at -2, and then we're going up 1, right 2, because the slope is 1/2. Down 1, left 2. I'm going to label that as my inverse. Okay, so now we are determining if the relation and inverse is a function. Remember, we talked about this yesterday. A function, all of your x's have to be different, and then we can use a vertical line test in order to determine if they are functions on the graph. So relation, remember, is the original, which is the blue one. So yes, that would be a function. None of your x's repeat. And then your inverse, which is the pink one, that's also a function. Notice they're both linear. Anytime you have a linear equation, if there's a slope, then you will always be a function. All right, now let's move on to this last one. So notice this one, we're starting with a quadratic. So remember from the front, if we start with a quadratic, the inverse is a square root. So let's go ahead and change our f of x to a y, same exact thing. Remember to find your inverse equation, you're switching your x and y. Remember not to take that squared with it. You're just replacing the y with x and x with y. So getting y by itself, I'm going to subtract 1. And then I'm going to take the square root of both sides. So y equals square root of x minus 1. But remember, positive and negative when you take the square root of both sides. And then I'm going to go ahead and, since we started with function notation, I'm going to label it that way. So there's our inverse equation. So now I'm going to go ahead and graph y equals x. And then I'm going to graph the original. So it's a quadratic. Remember, the parent function is x squared. So if we have a plus 1, that's going to go up 1. So I'm going to shift my vertex from the origin up 1. And then I'm plotting the same points that we would from our parent function from that new vertex. So I'm going to go right 1, up 1 for that point 1, 1, because we square 1 and we get 1. And then if we plug in a 2, we get 4. So from that vertex, we're going right 2, up 4. And then 3, 9. So again, from that vertex, 3, and then 9. And then we know we can reflect those points to find the other part of the parabola. Again, if you don't want to graph it that way, if you just want to pick some points, x values to plug in and find y, you can do that also. Just not using a calculator. All right, so this on this relation, or the inverse graph, it's a square root graph. We have not talked about a square root graph in Algebra 2 yet. So we're going to just make a table here. And notice we're dealing with a square root here. So if we're plugging in some x values, we're going to need it to be a positive number under the square root. So if we were to plug in, just say -2, that's going to give us a -3 under the radical, which isn't going to work. That's imaginary. So I'm going to plug in the smallest number I can plug in to not get a negative would be a 1. If I plug in a 1, 1 minus 1 is 0. So square root of 0 is 0. Then I'm going to plug in, let's see, 2. Let's see if 2 would work. 2 minus 1 is 1. Square root of 1 is 1. And then let's think about 3. Plug in a 3, you get 3 minus 1, which is 2, but the square root of 2 is a decimal. I don't want to deal with that. So the next perfect square would have to be a 4. So I would need the x to be a 5. 5 minus 1 is 4. The square root of 4 is 2. So you might have to think a little bit on what values we can plug in and not get a decimal. So I'm going to go ahead and graph those points, and then we'll talk about it. So 1, 0, 2, 1, 5, 2. Now, if you remember from yesterday when we were graphing, when you reflect over the line y equals x, that parabola becomes a sideways parabola. So we only have half of this. That is the reason why we need positive and negative in front. So really, when we plug in a 2, we get 1, but we also get -1 because of the negative in front. When we plug in a 5, we get 2, but we also get -2 because, again, we have a positive and a negative in the very front of that square root. So if you plot 2, -1, it's just a mirroring image across that x-axis there. Okay. All right, so again, make sure that you finish out your parabola on that one. Okay, so there's my inverse. So I'm just going to label that graph there. So we are looking at the relation, which is the blue one. That would be a function, because if we use the vertical line test, it passes, no repeating x values. And then the inverse, if you look at the pink one, that would not be a function, because if you use the vertical line test, it crosses at multiple points. So that's a no. Also, remember yesterday we talked about if we only had the relation, which is the original, we could use the horizontal line test on that one to determine if the inverse is a function in 1-to-1. And clearly, if we use the horizontal, it crosses at 2 places. So we know that inverse is not a function there.